All right, guys, Mr. Gucci here with your last help video for the 12.2 worksheet. We are going to do numbers 13 through 15, all right? Now, this is a multi-part problem that I have broken up for you. Here's how it goes. If you have 630 grams of super chilled ice at negative 69.2 Celsius, how much heat will it take to fully melt the ice? Now, there's no one equation that can tell you this because, in fact, two things are happening. The first thing that's happening is you are warming up the ice from negative 69.2 degrees Celsius to zero. All right. And that is a Q equals MC delta T equation. How much energy does it take to take a certain mass of ice and warm it up a certain amount? All right. The next thing is once you have ice at 0 degrees Celsius, how much energy are you going to need to fully melt it? So problem number 13 is like problems 1 through 8, Q equals MC delta T. Whereas problem number 14 is like problems 9 through 12, where you use Q equals M and the heat change of a phase. All right, so let's set this up. I will do 13 first. So problem 13. All right, the energy needed to take a mass of ice and heat it up by a certain temperature. We're trying to find the energy, nothing complicated here. All right, the mass of the ice is 630 grams. All right. The specific heat of ice is 2.11 joules per gram degree Celsius. And the change in temperature of this ice is, well, if it goes from negative 69.2 to 0, that's an increase of 69.2. And we just multiply that together. 630 grams of ice times 2.11 joules for every gram you want to increase, times 69.2 total degrees you are increasing it by. And we get 91,987.6 joules of energy. That's how much energy it takes just to get the ice to its melting temperature. And again, that's 91,987 joules. Cool. That's how much energy it takes to warm up the ice. Now we want to know how much energy do we need to melt the ice now that it's there. So, number 14. The energy we need to melt this ice is equal to its mass times the heat of fusion for ice, the melting energy for ice. Now, mass, we still have 630 grams. It does not change just because we got it warmer. And the heat of fusion for ice, the energy that it takes to warm up or to melt ice is equal to, and let me go to the worksheet. The energy needed to warm it up is 334 joules per gram. It takes a lot more energy to change something's phase than to merely get it a little bit warmer. So the energy it takes to melt this ice is equal to 630 times 334. And I got 210,420 joules. 210,420 joules. All right, great. Now, I want to know how much energy this is altogether. And so all I do is add these two values. It took 91,987 joules to warm the ice up, plus 21,420 joules to melt it. That's a grand total of 302,407 joules to do the whole deal. When you are dealing with both temperature change and phase change at the same time, you must break the problem into every temperature increase and every phase change, and then add them all together. Guys, I hope this video was helpful. Good luck.